Before we start this lesson, I just want to quickly say well done for making it through to the final lesson. There was a lot to cover over this course, and for those who knew nothing about code or programming audio, it can be tough to take it all in at first, so the fact that you're here at the final lesson is something you should definitely be proud of, and I've certainly enjoyed making it here with you. But in this final lesson, we're going to be talking about FMOD Soundbanks. We're going to be taking a step back to learn a little bit about the physical side of how audio is loaded into games. We'll then look at how banks relate to that, and why they are important, and how we store our audio inside of them. Finally, we'll see how we can interact with banks in C#, some ways we can utilize the runtime manager script we've looked at previously in order to do this, and how we can use the FMOD Studio bank loader component. Awesome, so let's get started with our final lesson. Let's start by looking at a very basic explanation of how a game displays data for us to interact with. Now, the three main parts to any console or computer that we'll be looking at are the storage device, RAM stick or memory, and CPU. Before we launch our favourite game, all of the game's data is stored within the storage device, which can be a hard drive or an SSD. This data includes everything that makes up our game, such as our code and scripts, art, animation, and most importantly to us, our audio. And when we first launch our game, it will start a loading process, and during this process, our computer is loading any data the game might need to use from the storage device to the RAM. Then, as the data becomes required by our CPU to display to our player, the RAM sends it to the CPU to be used. Once it's been used, it returns to the RAM, and if it's no longer needed for the time being, sent back to the storage device via a process called garbage collection. Now, to understand why we should care about FMOD Soundbanks, we'll be focusing on both the RAM and the process of loading information from the storage device to the RAM. Now, RAM acts as a middleman between the storage device and the CPU. Where a storage device can hold a large amount of data, it becomes very slow at processing and sending that data between components. A CPU, on the other hand, is extremely fast at processing data, but doesn't really hold data, it just makes it usable or readable or tells it to do its job. Now, RAM sits in the middle and can only hold so much data, but at the same time can process it faster than a storage device. If the storage device had to send data directly to the CPU, there would be multiple long pauses in between your gameplay as your device tries to retrieve the new data it requires for the game to continue. That's why games load data up front during a loading screen. What it's doing during this time is it's actually gathering all the data it needs from the storage device and storing it temporarily in the RAM. Then when some new enemy needs to be spawned in, for example, it can quickly be pulled from the RAM and displayed on your screen by the CPU. So think of this process like a cake shop where the storage room out back is the storage device in our computer, the front display is our RAM, the customer is the CPU, and the cakes themselves are our data. And just before the shop opens, the manager will take all of his cakes from the storage room and place them in his display ready for the shop to open. This allows the customer to quickly buy the cake they want. If, however, the front display didn't exist, the manager would have to retrieve the cakes from the back storage room whenever a customer wanted to buy one, causing them to wait longer than they should have to for their cakes. If you want to learn more about the process of data passing from the storage device to the RAM, there is a great video I'll have linked under this lesson for you to watch that explains the process of loading in more detail. But with that, you should now understand enough about how computer hardware processes game data for us to look into FMOD Soundbanks. So all the way back in the Event Instances lesson, we very briefly discussed how a bank is a file that holds our audio and information on how to play it in our game. And since then, whenever we have created a new event, we've assigned it to the default master bank that every FMOD project must contain. Well, that file is called a .bank file. Because we've previously built this bank file in FMOD, we can actually find it in our game's assets files. So to find it, you're going to need to open up your File Explorer or your Finder if you're on a Mac, and navigate to the location of your Unity projects folder. Now for me, that would be in my Documents, Unity Projects, 3D Game Kit, Assets, and Streaming Assets folder. And here you can see the masterbank.bank file. Now if your bank is not here, it may be because you chose to save it in a different location during the integration of the two projects back in the setup lesson. If we go into Unity, select the FMOD tab and click Edit Settings, we've got an option here called Import Type. As you can see, mine is set to the default Streaming Assets folder, which was the folder I just searched through to find my .bank file. Now, if you've got yours selected to Assets Bundle, you might have it saved inside a different folder, which it allows you to select here. Once you've found where your banks are being saved, you should notice at least 2 files, and maybe more if you've made changes to your settings in FMOD. There should be at least a masterbank.bank file and a masterbank.strings.bank file. Now, bank files contain 2 types of data called meta and sample data. Metadata contains information about an event we've created and assigned to that bank, parameters we've created and set values to, modulators we've used, and nearly all of the FMOD information about how to play back our audio in the game. By loading this type of data into our game, Unity is able to read this data to learn how to play back our FMOD events when told to. For example, if you want to set up an event to loop in FMOD, Unity will read this data and loop your event when played. Now, sample data, on the other hand, contains information about the audio files themselves used by the events assigned to that bank. And those files are also encoded into a new format for our game to read. For our game to play an event, it needs both the metadata of that event and the sample data of the audio used in the event. Sample data also contains information on assets that are to be streamed. In FMOD's audio bin or FMOD's asset browser menu, you should have the option to set a file to be streamed when loaded into the game. For example, you should have your gameplay music file set to stream, but if you don't, you can just select the stream button under loading. This tells our game to load this particular file straight from the storage device, bypassing the RAM when needed. And this is typically used for larger files that might take up a lot of the RAM's memory, which gives the RAM more room for other assets. And because this process avoids RAM, it takes longer to be loaded in, causing a slight delay between when it's told to play and when the player actually hears it. Because of this, it's best used for long ambience or music files that don't need to be heard instantly when told to play, or fade in gradually, so that the time taken to load the file is not noticed by the player. And FMOD also gives you the option to separate the meta and sample data of a bank into separate files, allowing you to load them in at separate times. You can access this menu by going to Edit, Preferences, or if you're on a Mac, I believe it's under File Preferences, and then selecting the Build tab. So if you noticed earlier you had a few extra files, this section is likely why. If you wish to, you can even organise the banks you've made for specific platforms, such as different consoles that you might be playing your game on. Now, the masterbank.strings.bank file specifically contains name information on all of our FMOD events, even if those events are not assigned to the masterbank itself. So in our scripts, whenever we've told our code to create an instance of a specific event by name at runtime, Unity has then searched through this file to find the event we were referencing. And the masterbank itself also contains information about our mixer and buses, including the master bus. Because of this, it must always be loaded into RAM at runtime. Otherwise, there will be no master bus loaded in for our audio to pass through and get sent to the player's speakers. So up until now, whenever we've made a new event in FMOD, we've been assigning it to the master bank as a quick and simple way to get the event to play back in Unity. And practically speaking, this is actually a bit of a bad approach. As we discussed earlier, RAM has a limited amount of space for game data, and therefore it is vital we only load audio that is absolutely needed for any given moment in time. For example, we don't need to load any sounds or events that will only be used for the first level of our game, such as the staff collection sound we implemented in the Play One Shots lesson, if the player is currently running around level 2 where the sound is not used. So to manage what events and audio is loaded into RAM, we can create multiple different sound banks for different purposes. And creating a new bank is simple. If we click on the Banks tab, where we can see our one and only master bank, we can create a new one by right-clicking and selecting New Bank. We can then give it a name. And the first bank we're going to make is going to hold all of our events that play sounds made by Ellen. So let's call this bank Ellen. Let's then open up our master bank and we're going to select all the events that are to be played by Ellen, and we're going to store them into the Ellen bank like that. Now we're also going to create 4 more banks. One called Music for any events that play music. One called UI for events that play when the player is interacting with the game's menus. One called Environment for any sounds played by the environment. And finally, one called Level 1 for sounds that are only played during the first level. Then from the master bank, we're going to reassign the level test event into the UI bank, the gameplay music into the music bank, the Fireflies event into the environment bank, and finally the staff collect and teleporter events into the level 1 bank.
Now, if you've been taking part in the challenge videos of each module, you'll also have a few extra events left over. The running water, the 2 chomper events, and the health crate event. Well, the running water event can be added to level 1 as it only appears there, and then the rest can go into environment as they appear in both the 2 main levels.
Once this is done, we can now press F7 to build all of these new banks. Then if we go back to our streaming assets folder and just wait for it to load in, there we go, we should see it update and add all of our new banks. Now it's time to see how we can load and unload these banks into our game at runtime. Before we start this, however, we're going to take another look at the FMOD settings page, as there are some options in there which will affect how our banks are loaded. So if you're using a version of FMOD that's older than 2.0, this is the section you will be interested in. It's called loading, and by default, load all event data at initialization should be ticked. This means that every event and every bank in your FMOD project will be loaded during the startup of the game. Now, initialization is a process that the script titled FMOD that we looked at way back in our namespaces lesson will perform. To put it extremely simply, it's a process of turning the FMOD API and all of the scripts using the API on. And thanks to the FMOD script, it happens as soon as the game starts. So in other words, with this box ticked, the game will load all of our events and banks when we first launch the game. Now, this has been fine for us so far whilst we've been testing our events and our scripts, but if we were working on a larger project, we probably won't want all of our data loaded in straight away, especially if it's not being used. So we're going to untick this box. The other option here, which has now been grayed out, is load all sample data at initialization. So if both boxes were ticked, all of our events, banks, and audio files will be loaded into the game when it is first launched. Now, if you're using FMOD 2.0 or higher, you should have a section that says initialization. Here you have the option to pick specific banks to load during initialization. You can either have all of them load, which is what the default option is. You can specify which banks you'd like to load, or you can have none load during initialization. If we click specified, you get a little drop-down menu that allows you to select which banks you'd like to load. We click add bank, for example, we can then browse through our banks and choose which of our bank files we'd like to load. We can also select add all banks, or we can clear any banks we've currently selected. However, for us, we're going to want to select none. You also get the option to decide whether or not you want to load in the sample data associated with those banks when you specify which banks you're loading in. And because we've selected none, no sample data will be loaded in during initialization. Great, so now that none of our banks will be loaded in, let's quickly see what happens when we try to play our game. Now, as you can see, we get instantly a lot of errors in our console tab as our code is trying to access data that hasn't yet been loaded and therefore can't be found. So in order to learn how to load banks into scenes, we're going to need to go through each of the 3 main scenes in this game and load the appropriate banks for each of them. Now let's start by going to the start scene by selecting our project tab, going to Assets, 3D Game Kit, Scenes, and then selecting the start scene. Now so far we haven't yet added any sounds to this scene, so before we look into how we load banks, let's quickly add some components that will try to play some of the sounds we can test to see if our banks have worked. So the first thing we're going to do is add our music event. So we're going to select the level 01 music object. Then we're going to click Add Component. We'll then search for the music player script, add it, and then we search for the music event we want to play, which is gameplay music. Let's also add the components we need to link our buses to the audio settings sliders. So let's select the Options Canvas Master object, Audio Canvas, and then BG. Then for each slider, like we've previously done, we're going to remove the Mixer Slider Link component. We're then going to search for our F_bus control script. We're going to choose the path. So for the master volume slider, we're going to leave it blank. And then on the on value changed box, on the slider component above it, we're going to press the plus. Then we're going to drag the object into the object reference box, select our F_bus control script, and select volume level. Once you've done that, make sure you go ahead and do it for the rest of the game objects. Remembering to add the correct path for each. So for example, write music for the music slider. And now this scene will have music. allow us to adjust the levels of our buses, and also play the level test event for the sound effect slider. Once you've done all that, you're all set. So to load the correct bank for each scene, we're going to use a component that comes with the FMOD integration package for Unity called the Studio Bank Loader, as it allows us to load and unload multiple banks at once using functions such as start, on destroy, and on trigger enter. First, let's create a new empty game object and we'll call it Bank Loader. Then we're going to click Add Component and type Studio Bank Loader. And then the FMOD Studio Bank Loader is the component you want to add. As you can see, it's a pretty simple component. You just click Add Bank, search for the bank or banks you'd like to load in, and then choose how you'd like them to load in.
So before we start loading in our banks, let's talk a little bit about how the 3D Game Kit has structured its levels, as this will help us understand when it's best to load in the banks. After we've launched the game and FMOD's API has been initialized, the player begins in the start scene or level. From there, they go to the first level and then the second, and then once they finish the second, they'll end up back at the start. They can also restart any level from the pause menu, which is treated as an unload and reload of that scene. So the most efficient thing for us to do then is at the start of each level, load all of the banks needed for that level, and then unload them again once the level has finished. Then once the next level starts, we'll load in the banks needed for that level. This way, whether the player transitions from one scene to another or restarts the one they're currently in, all of the correct banks will be loaded into the game. The only exception to this will be the master bank and the masterbank.strings file. For us to be able to hear any audio in our scenes, we need to make sure that the master bank is loaded in, as it contains data used by all of our events. For example, which buses they are to be played from. The masterbank.strings file is just as important. We need it loaded so that we can retrieve events, parameters, or buses by their names in our code, which we've been doing frequently throughout this course. So because of this, they'll be loaded during initialization of FMOD's API as the game is first launched. This saves us from unloading and then reloading them between each transition unnecessarily. Okay, so with all of that in mind, the first thing we're going to do with our bank loader is choose the two banks we'll need for the start scene. So let's click Add Bank, let's search for the music bank, and let's also make sure we search for the UI bank. Now let's tell our bank loader when to load and unload these banks. Next to load, we're going to select Object Start to load them in on the first frame of this scene, and then next to unload, we're going to choose Object Destroy, which will unload them when our bank loader object is destroyed at the end of this scene. Now underneath, we have an option to preload sample data that's associated with these banks. When this is ticked, this will load all of the sample data that is to be used by the events associated with these banks, as well as all of their metadata whenever we tell them to load. If it's left unticked, however, then only the metadata will be loaded when we tell our banks to load. The sample data will then be loaded as it's needed by each event when the event is told to play. So for example, if we left it unticked, we could load in the UI bank on the first frame and our level test event would be loaded in with it. However, the actual audio files that we're using inside of that event won't be. Instead, they won't be loaded until the moment when the player adjusts the sound effects slider in the pause menu, triggering the event to be played. The upside to preloading sample data then is that all of your audio is loaded and ready before the event is played. If you wait until the event is told to play then, you risk causing a slight time delay between when the event is told to play and when the player actually hears the audio, but will save time loading data up front. So in our case, it makes sense to preload the sample data with the metadata during the loading screen just before the scene starts, so that there's no delays between when the events are told to play and when we hear them. Now that our banks for this scene are set up, let's go to the FMOD Settings tab so that we can tell our master banks to load in during initialization. Under Load Banks, let's select Specified. Then let's click Add Bank and then let's browse for the master bank. Let's do the same thing and browse for the masterbank.strings file. Notice how we also have an option for loading sample data for these two banks. Now, seeing as we're only loading in our master banks here, and that they don't contain any sample data anymore, we don't need to tick this box. Now, if you're using a version of FMOD older than version 2.0, you can instead load your master banks in and out of each level with the rest of your banks in your bank loader. Now that this scene is all set up, let's give it a save and then make our way over to the first level where we can start adding in banks for that. Now that we're in level 1, just like before, we're going to create a new empty game object. And we're going to call it Bank Loader. We're then going to add the FMOD Studio Bank Loader component. And we're then going to add the Ellen Bank, the Environment Bank, the Music Bank, the UI Bank, and finally the level 1 bank. Just like before, we're going to load all these banks on the first frame, and we're going to unload them when this object is destroyed, and we're also going to preload all of the sample data associated with the events inside these banks. Then let's save this scene, and to save some time, let's copy the bank loader object we just created. Then we can head on over to level 2. Inside level 2, all we need to do is come to our hierarchy tab and then paste in our bank loader object. Then the only change we need to make to it is to remove the level 1 bank, as we don't need it for level 2. Once done, we're all set to save our scene. Once you've done that, head on back over to the start scene where we can test our game. So as you can hear, when we start the game up, we can hear the music playing as it should because our music bank has been loaded in. We can then go into options, select audio, and we can adjust the sound effects volume slider and hear the UI level test event play. If we then go back and click start, we can move on to the first level. As the level starts, we can hear that our music is playing again, meaning the bank successfully unloaded itself and loaded back in. If we then walk around, our new banks such as the Ellen banks have also been loaded in, as proved by Ellen's footsteps. If we collect our staff again, we can hear that the level 1 bank has also been loaded in. Now if you wish to keep testing for every bank, you can continue on through this level and go into level 2 in your own project. But now it's time to look at the actual lines of code we can use to load and unload these banks. Okay, so whilst the Studio Bank Loader is a great option, you might wish to have a little more control over your bank loading. For example, you might wish to load in a bank based off another function, or first check to see if a specific condition has happened in your game using an if statement. Now normally when using FMOD's API outside of Unity, you'd have to learn about and know how to use multiple systems, such as loading sample data separately from metadata, creating bank objects that hold a reference to each bank, using FMOD's flag system to declare whether or not you want the bank to load whilst the game continues to play, and so on. Now all of these principles I'll have linked under this lesson if you wish to read up and learn more about them, but to make things easier for us, the Runtime Manager class that we've been using throughout this course has pre-programmed functions that utilize these systems for us. So in this empty class, I'm going to quickly share with you how to use those functions in your own scripts. Now first we need to find a particular way we want to load in a bank. Now the easiest way is to create a public string and then use a new attribute specifically for referencing FMOD banks in the same way we reference events. This attribute is fmodunity.bankref. And because I've got the namespace at the top, I don't actually need the namespace in the attribute. This allows you to use that public string in the inspector tab to search for the bank itself. So for example, we could search for the master bank. Alternatively, in FMOD, you can select one of your banks, right click it, select copy GUID, and then store the GUID inside a string to be used to reference the bank you're after. Just like that. Then in one of our functions, so we can access our runtime manager and add .load bank. Now the load bank function is actually the same function that our Studio Bank Loader uses. So if we right click this function and select go to definition,
will be taken to the runtime manager script where it was first declared. So we can see that for this function to work, it requires two arguments. A string, which will hold a reference to the bank you're loading in, and a boolean to know whether or not to load the sample data from the bank up front, just like the tick box we looked at on the Studio Bank Loader. So in our script, we'll give the bank loader function our string, which holds a reference to the master bank, and we could feed our own boolean variable into it to dictate whether or not we load sample data up front, but we can also just write true or false. Now the other function we can use from the runtime manager class is unload bank. Now this works exactly the same way, except this time we don't need to give it a boolean, as we're unloading the bank and it's containing sample data at the same time. It is important to note, however, that if you're loading the sample data from your banks up front multiple times before unloading it, the amount of times loaded is counted and remembered. You will then have to unload the bank's sample data the same amount of times you loaded it in. Now, whilst you can unload the sample data separately from the rest of the bank by using other lines from FMOD's API, the runtime manager's unload bank function will do both anyway. So just make sure that if you load a bank and its sample data together more than once, that you then call the unload bank function the same amount of times to completely remove the data from the RAM. The last function you can use is actually one that returns to you a boolean value. It's called anyBankLoading, and it checks to see if you're currently loading any of your banks into your game. You can then use this to check to see how long a bank is taking to load, or set up other audio events to play after the bank has loaded fully. If we check it out in our runtime manager class, notice how when the function has been declared, the word void is missing, but instead in its place, the data type boolean has been declared. Now, whenever you see a function that has replaced the word void with a data type, it means that this function must return a value of that type. Now, also notice the keyword return at the bottom of this function. Using this keyword and then following it up with something that holds the same data type as the function requires will take that data and return it to the function, which is the result it will output. Now in this case, when the function is first called, a new boolean variable called loading is declared and set to false. Calculations are then made to determine whether or not it will remain false or change to true. Once they've been made, the function is told to take that variable and return its value out for us to use. So going back to our script, the simplest way for us to utilize this function would be to place it inside of the debug.lock command. Now on every frame, because we put it in the update function, the anyBankLoading function will be called, and in the console tab in Unity, we'll either see the word true if a bank is being loaded in, or false if it's not. You could then even make it the result of an if statement. If we were only interested in checking it if it returns true, we could write the name of the function itself inside the condition brackets of the if statement. Now you'll only see a message in the console tab when the function returns true and a bank is loading. Alternatively, you could check to see if it's ever false to do the opposite. So essentially, anyBankLoading acts both like a function because we can tell it to do certain commands and perform certain tasks, but also acts like a variable as it can hold data for us to use later on. Now whilst there are a couple more, those are the three main public functions you can use from the runtime manager when loading banks. So those are the essentials you need to know when it comes to loading FMOD banks into Unity. We now know how the physical components of a computer or console play an important role when managing the data that contains our audio. We also know how we can make bank files in FMOD to hold our audio as compacted data files. And we also now know how to both use the Studio Loader component and the functions provided to us by FMOD's runtime manager script to load and unload our banks into and out of our game when necessary. And with that, you've just finished the FMOD and Unity Essentials course, so congratulations! There's been a lot we've covered over these lessons that you can use to put your own audio into Unity games all by yourself. And now that you've gone through every lesson, I encourage you to go back to some of those from time to time as you start implementing more audio for different purposes, to keep the knowledge clear to you. But don't worry, because that's not completely the end of this course. Now that you've purchased it, you'll gain access to any and all updates, new content, and extra features that will come to this course in the future. Both Unity and FMOD are always changing, and as well as adding more lessons about extra features we can use down the line, updates are inevitable, so thankfully, when new lessons come to cover those topics, you won't have to purchase anything else to access them. Now, on a personal note, thank you so much again for not only giving this course a try, but seeing it through till the end. I hope you found it helpful and have enjoyed implementing your own audio as much as I have creating this course for you. And if you have any questions about the future of this course or any issues you'd like to talk to me about, you're more than welcome to email me at henry@scottgamesounds.com. Now, thank you one final time, and I wish you all the best in your game audio adventures.